On July 10, 1994, a barge anchored itself over an empty patch of the Arabian Gulf, roughly 280 meters off the coast of Dubai. There was nothing there, no island, no foundation, no bedrock waiting patiently below the surface for someone to build on top of it. Just open water and a set of buoys marking a location that, on paper, was about to become the site of one of the most photographed buildings on Earth. In reality, it was still just sea. 5 years later, a 321-meter tower shaped like a billowing sail rose out of that exact spot, standing on an island that had never existed before construction began. It cost roughly $1 billion to build. It employed thousands of workers from around the world, and it turned a relatively unknown desert emirate into a name recognized on every continent, years before most of the skyscrapers that now define Dubai's skyline had even been designed. It remains, to this day, the tallest building in the world, used exclusively as a hotel, and for years it was marketed, unofficially, as the world's only 7-star property, a label that never officially existed anywhere in hospitality, but stuck in the public imagination anyway. This is the story of how the Burj Al Arab got built, starting from a stretch of empty ocean that had to become solid ground before a single wall could go up. The idea behind it began, fittingly, with a single sketch. In 1993, Dubai's ruling family approached the British engineering and architecture firm Atkins with an ambition that had almost nothing to do with practical hotel design and almost everything to do with symbolism. They wanted one image, one building, something the world would recognize before it recognized Dubai itself, the same way people instantly picture the Eiffel Tower when they think of Paris, or the Opera House when they think of Sydney. The architect handed the brief. A young designer named Tom Wright sketched a concept built around one of the oldest silhouettes in Arab maritime history, the sail of a traditional dhow, the wooden trading vessels that had carried goods along this coastline for centuries. Wright later said the client explicitly wanted a building that would become an iconic, symbolic statement for the country, something synonymous with the name Dubai itself, the same way a single landmark had already come to define other great cities around the world. It was a deceptively simple idea. Turning it into a 300-meter structure standing in open water would prove to be anything but. Before a single steel beam could go up, engineers first had to solve a problem most buildings never have to think about at all. There was no ground to build on. The site sat in genuinely open sea, and the bedrock strong enough to anchor a structure. This heavy sat more than 180 meters beneath the seabed, far too deep to reach with any conventional foundation. So the engineering team, led by Atkins and constructed by the South African contractor Murray and Roberts alongside Al Habtoor Engineering, made a decision that would define the entire first phase of the project. Rather than reaching down to bedrock, they'd rely entirely on friction, driving concrete piles deep enough into the sand and silt that the surrounding material itself would grip them tightly enough to carry the enormous loads above. That meant driving 230 individual concrete piles into the seabed, each one 40 meters long and 1.5 meters in diameter, using a hydraulic hammer mounted on a floating barge, since there was no dry land anywhere nearby to work from. Each pile had to be driven deep enough that friction along its entire 40-meter length, rather than any solid rock beneath it, would be strong enough to support the structure. Every single pile was load tested before construction could move forward, because a single weak pile, buried invisibly beneath what would eventually become tens of thousands of tons of concrete and steel, could compromise the stability of the entire structure sitting above it. 2 rigs worked simultaneously to keep the schedule on track, since with 230 piles to drive, there simply wasn't room in the timeline for delays. To an observer standing in a boat above the site during this stage, there was nothing visibly resembling an island at all, just a scattered field of pile heads poking above the waterline, the buried roots of a building rather than anything you could call land. Once those piles were in place, engineers still didn't have anything resembling solid land. What they had was a forest of concrete columns rising invisibly out of the seabed, marking the footprint of a building that technically didn't have anywhere to stand yet. Temporary sheet piles were driven in a ring around the entire footprint, holding back the surrounding sea, while the real island was built inside that boundary. Rock and specially designed concrete armor units, some of the first of their kind, used anywhere in Gulf construction. Were placed around the perimeter, specifically engineered to absorb and dissipate wave energy rather than simply blocking it outright, protecting the emerging island from the kind of 100-year storm waves the Gulf could realistically produce. With the perimeter secured, crews began pumping hydraulic fill, a slurry of sand and water into the space enclosed by those sheet piles, gradually displacing the seawater and building up dry land, where there had only been ocean weeks earlier. The process demanded genuinely precise control. Pump the fill in too quickly, and the pressure could buckle the surrounding sheet piles. Pump it in too slowly, and the entire construction schedule would start slipping. Workers measured the fill level continuously, hour by hour, as the slurry gradually settled and the water drained away. And for the first time, Solid ground began to appear exactly where open sea had existed only months before. That new land still wasn't stable enough to build on, though. Loose, saturated sand can't reliably support a structure this heavy, so vibratory compaction probes were driven repeatedly through the fill to force it dense enough to actually bear real load. More armor rock and concrete honeycomb blocks, again a first for Gulf construction at the time, were layered over the surface, designed to let wave energy bleed harmlessly through the structure rather than slam directly into it. The resulting seawall rose 7.5 meters above sea level, tall enough that a genuine 100-year storm surge still couldn't reach the lowest floors of whatever eventually got built on top of it. It took roughly 3 years just to reach this point. 3 years of pure marine engineering before a single wall of the actual hotel had gone up. Longer than it would ultimately take to construct the entire building standing above it. Once the island itself was finally complete, dry, compacted, and waterproofed, the pile heads supporting the future structure were trimmed to an exact uniform level, each one cut to within 5 millimeters of the design elevation, because the enormous concrete raft that would eventually sit above them needed a perfectly flat surface to bear down on evenly across all 230 piles. A waterproof membrane was heat welded across the entire base, engineered to hold back Gulf seawater trying to push upward through the foundation for the next century of the building's life. Then came the raft itself, a single continuous concrete platform roughly 70,000 cubic meters in volume, reinforced with a dense cage of rebar tying every one of those 230 pile heads together, so the enormous load above would be shared evenly across the entire foundation rather than concentrated on any individual pile. Hundreds of workers spent weeks tying that steel cage by hand across the full footprint of the island, with every individual pile head-wrapped and secured before the concrete pour could even begin. The pour itself couldn't simply stop and restart, because any interruption would create what engineers call a coal joint, a permanently weak plane running through concrete that's meant to behave as one continuous, unbroken mass. So the pour ran around the clock, day shift into night shift, workers driving vibrators through the wet concrete constantly to eliminate any voids or air pockets that could compromise the raft's strength decades down the line, with laser-guided screeds dragging the surface flat, so every column that would eventually rise from it started from precisely the same reference plane. Cooling pipes had been cast directly into the concrete before the pour even began, because a mass of concrete this large generates enormous heat as it cures, heat that, left unmanaged, would cause the raft to crack from the inside out. For weeks afterward, cold water ran continuously through those embedded pipes, while engineers logged the internal temperature hour by hour, keeping it below a safe threshold until the concrete had fully cured. Wet Hessian burlap was draped across the entire surface to control how quickly the concrete dried, since curing too fast risked shrinkage cracks, while curing too slowly risked delaying the schedule, and specially calculated water stop joints were cut at intervals across the raft to let it safely expand and contract with temperature for the rest of its working life. Only once that raft was complete, roughly 70,000 tons of reinforced concrete resting on 230 piles driven into the Gulf seabed, did the actual hotel begin to rise. Construction of the tower itself used a technique called jump form, essentially a section of formwork built around the building's concrete core that literally climbs the structure as it rises, or jacking itself upward, floor by floor, rather than relying on scaffolding built up from the ground. Workers quite literally rode the formwork upward as they built, pouring a section of core wally, letting it cure enough to bear load, then jacking the entire form assembly up to the next level and repeating the process again. Alongside the core, table forms, each roughly 18 meters long, engineered to handle post-tensioned concrete floor slabs that used considerably less steel and allowed for a faster construction cycle than a conventional reinforced slab would have. After each floor was poured, steel tendons threaded through ducts cast into the slab were stressed and locked under tension, putting the concrete permanently into compression and giving each floor its structural strength. Then the same table forms were stripped, flown up to the next level, and the entire cycle repeated. Pour, stress, strip, fly. Workers did that 56 times before the core finally topped out at 321 meters above the Gulf. Around that concrete core, a 9,000-ton steel exoskeleton was assembled, delivered to the site by barge and lifted into position section by section, bolted onto anchor plates that had been precisely cast into the core walls weeks earlier during the concrete pours below. This steel frame wasn't decorative, it was genuinely structural, engineered specifically to resist the enormous wind loads. A building this tall and this exposed would face standing directly in the open Gulf, with diagonal cross-bracing bolted in at intervals to dramatically increase the frame's overall stiffness against those forces. Workers climbed that exposed steel grid with nothing but a harness between them and open water hundreds of meters below, bolting each connection to exact specification, because every single one of those bolts was carrying real structural force the moment it went in. One of the most striking individual elements of the entire structure, the Al Muntaha restaurant, was cantilevered 27 meters out from the building's south face at roughly 200 meters above the water. Assembled section by section and engineered to appear far more delicate than it actually is, a deliberately dramatic piece of over-engineering built specifically to look like it shouldn't be possible. Higher still, at around 210 meters, workers bolted together the radial steel beams and deck plates that would eventually become the hotel's helipad. Standing on a platform suspended directly over open sea, long before that platform had any railing or safety net beneath it. Once the steel exoskeleton was essentially complete, crews began installing the building's most iconic feature, its Teflon-coated woven fiberglass sail facade, made up of individual panels each cut to the precise, unique geometry of the curving exoskeleton grid beneath it, meaning no two panels were ever quite identical. Each panel was fitted with edge fixtures designed to carry the full tension load once stretched taut across the frame. Hen hoisted into position and tightened at every corner using turnbuckles until it read cleanly across the steel structure. Workers physically tapped every finished panel surface to check for slack, because a panel that fluttered in the Gulf's constant winds risked tearing within a year of installation. Panel by panel, floor by floor, the building's silhouette slowly transformed from bare, exposed steel into the unmistakable white sail Tom Wright had first sketched back in 1993, culminating in the panels at the very top of the mast, rigged into place roughly 300 meters above the water. With the exterior largely complete, attention shifted inside to an interior built to match the ambition of everything holding it up. An atrium rising 180 meters, 18 stories of open space finished in gold leaf and Carrara marble, all supported by the very same concrete core poured years earlier during that first uninterrupted concrete run. Roughly 1,790 square meters of 24-karat gold leaf were applied by hand, one wafer-thin sheet at a time, pressed onto columns with brushes too delicate to safely handle with bare fingers. 202 duplex suites, every single one spanning 2 levels, were fitted out individually, with curved ceiling panels prefabricated off-site, specifically to match the unique curvature of each room, meaning genuinely no 2 suites in the entire hotel were exactly alike. Brazilian green marble was fitted across the walls of every royal suite bathroom, each slab carefully matched to its neighbor before the adhesive was allowed to set, so the veining would appear continuous across every joint. An enormous aquarium wall, built from panels of acrylic 18 centimeters thick, was engineered to hold back nearly 1 million liters of water under constant pressure. Custom carpets shipped in from South Africa and India were cut and fitted entirely by hand, corridor by corridor, meaning no 2 corridors in the finished hotel ended up quite the same either. Chandeliers imported from the United Kingdom were raised into position by hand winch, with every electrical connection made from scaffolding suspended above the finished floor below. Before a single guest ever set foot inside, the building went through an exhaustive commissioning process, floor by floor, basement to mast top. Every sprinkler head was tested, every fire damper was cycled open and closed. The main electrical switchgear was energized, and its protection systems tested under real load for the first time. Glass elevator cabs were run through their full travel range, from the lobby all the way to the top floor, long before any paying guest would ever step inside one. A 280-meter private bridge, the only way to physically reach the island by land, was paved, wired, and finally connected to the mainland, tying this entirely artificial piece of ground back to the city it was built to represent. The Burj Al Arab officially opened its doors on December 1st, 1999, 5 years after that first barge anchored itself over open water with nothing but a set of buoys to mark the spot. 230 piles, or roughly 70,000 cubic meters of concrete, 9,000 tons of structural steel, an island that hadn't existed 5 years earlier, carrying a building that, even now, still doesn't quite look like it should be possible, standing where it stands. What makes this project genuinely remarkable isn't just its height, or its cost, or even its now famous silhouette. It's the fact that literally none of it, not one pile, not one panel of that iconic sail, could exist without first solving a problem that has almost nothing to do with architecture at all. How do you build solid ground where there simply isn't any? Dubai answered that question with 3 years of pure marine engineering before the visible building even started, and in doing so, built something that became a symbol for an entire city before that city had built almost anything else people would recognize today. At the time it broke ground, Dubai's skyline was still overwhelmingly low-rise. There was no Burj Khalifa, no Palm Jumeirah, no Dubai Marina crowded with towers. This single hotel, standing alone on its own artificial island out in the Gulf, effectively announced the city's ambitions to the rest of the world before anything else had a chance to. Everything on Dubai's skyline that followed, in some sense, followed this. If you enjoyed this deep dive into how one of the world's most iconic hotels was built from nothing but open sea, make sure you're subscribed for more breakdowns of the most ambitious construction projects on the planet.